Alright, good morning. There are 2 questions left in this set. And we will finish this off and start review questions in exam 3. Just recall what this section was about. We were multiplying, dividing, adding, subtracting complex numbers. And division was the most complicated one because it involves multiplication, addition, everything. So we did the first 2 questions. The key trick here is you need to figure out what's on the bottom, take its conjugate, multiply both sides, and when you're multiplying, be careful. Sometimes you need to do conjugate multiplication, fast method. Sometimes you need to do FOIL, and you need to slow them and cancel those very well. Alright, we are in number 18 now. There is a complex number on the bottom. There's a complex number on the bottom, but top and bottom. But the one on the bottom is quite different than previous cases. Here at least you have one real part and one imaginary part. What you have here on the number 18 is just I. Sorry. Look, we have only I here, no real part. Here you have real parts and some i's. Well, do we care? No. Even you don't have anything in front, I can put 0, mark it 0, plus I if you wish. I can make it regular standard form complex number here, 0 plus I. So the idea is the same. You need to put these in parentheses. Actually, this doesn't require parentheses because 0 is not there, it's just I, single, but I will put it anyways. You need to put something next to these to multiply with and get rid of this I. So what is that going to be? I? Only I? What is conjugate of 0 plus I? So negative I, 0 minus I, or just negative I. Now once I recognize what the conjugate is, I want to clean this 0 up from here. I no longer need it. I just want to put there to observe a pair of numbers, 0 and I, so I can pick the opposite. So we will multiply this thing both sides by negative I. Okay? Now the top is used to be FOIL. We did FOIL on the top. Here it's not FOIL because this is a single term times 2 term multiplication. It's just straight distribution. Distribute I to both terms. It's not, you don't have to do FOIL. So there's 2 times minus I is minus 2I. 3I times minus I, positive 3 times minus 1I, positive 3 and minus 1 is minus 3. I times I is I squared. How about the bottom? I have 1I and negative 1I. 1 times negative 1 is negative, or positive negative is negative. And I makes I squared. Okay? Next. What is next? Are we done? We keep going until you get numbers on the denominator and combine like terms, cancel like terms on the top, combine any powers of I, multiply any powers of I. So there is some work to do here. What can I do next? Do I know I squared? Do we know what I squared is? Anyone?
Negative 1.
Negative 1. That means this one also negative 1. Alright, I can't do anything about the first one, it's just 2I. I don't know what I is, it stays. But minus 3 times minus 1 is positive 3. Minus 1 is positive 1. Well, if you have 1 in the denominator, you don't have to write it anymore. You can just ignore this denominator. It's 1. So the result is this. But I like number in front and then I term. Real part first, then imaginary part next. So can I flip these two and make positive 3 first and negative 2i next? 3 minus 2i is the answer. Okay? Alright. The last question is kind of different type question. Okay? Because why is it different? What is the first thing you notice? We have a radical. Yes. You don't have an I. Do you see? There is nowhere, comparing to this question to that, there is nowhere I. We don't have I on the bottom as well. So that's kind of good news. I is trouble. The reason we are doing all this conjugate multiplication is you have some i's on the denominator here, here, everywhere we had i's. We multiplied by conjugates here. You do not, again, you do not need to multiply by conjugates on this question because there is no I on the bottom. There is no I on the top yet. But there is a secret I. Where is it hiding? Where is the I on the top?
In front of 108.
Yep. This negative, a negative number under square root cannot be computed as a real number. It must be an imaginary number, so we need, this is a secret jail. We need to cure it, sanitize it by bringing the minus out. So you have minus 36 plus 108. Where is the I? Either you put in front or end, it doesn't matter, but it's outside the jail. Bring left or right, I don't care, out. Next, this jail has a big guy 108 inside. I believe some factors may pop up from 108 and break the jail, right? So why don't we factor 108 and see who comes out? Because I need to simplify this. I can't leave it like this. So how does 108 factor? Give me two numbers multiplying into 108. Pick two. 12 and 9. I think so. Yep, it works. Or you can go easy. 2 and 54. Just divide by 2 and see. It's divisible because the last number is even. You can go easy, but 12, 9 works. Can I break 12 more? 4 and 3 and 4. How about 9? 3 and 3. These are locked. They are not breakable anymore. Locked. How about 4? We can get 2 2's, so these are locked. So that's it. 108 is 3 cubed, 2 squared. Let me start with 2. 2 squared, 3 cubed. Well, it looks like these inmates have money. And the jail guard wants $2. It looks like this guy is paying off this and coming out. 2 is coming out. A 3 is too rich. 2 goes into 3 at least once. And there is one guy left inside, one guy out. One of the 3's come out, one of them remains. Because 3 cubed is 3 squared times 3. 1 remains, 1 out. So I will bring a 3 out, and then there will be a 3 to the first left, 3 to the first left, and all together divide by 6. Okay, let me pull those out and get this better. So 2 and 3 both comes out and combine in front, it's 6i. They make 6. And who's left inside? No more 2's, only 1 3 left. Okay? Are we done? I think we're done. I can't simplify this more. No. We have seen in this question, we have seen in that question, you cannot leave your answer with a big giant denominator division bar. You must always split this division bar into little pieces, separate it into pieces, and leave your answer as in the form a plus bi. So this 6 must split into two pieces as minus 36 over 6 and 6i over 6. And look what's happening. These are canceling. Because 6 goes to 36 6 times. 6 goes to 6 once. They cancel away. And what we have is minus 6 plus I root 3. Technically, I like I on the left, just like it says here. We like B, number in front of I. So I will flip the location of these two and make it minus 6 plus root 3 I. Just pay attention where I stands. Don't put it inside the jail. It's wrong if you put it inside. Make sure it's outside. So this was also division question. But where did the division happen? It only happened on the very end. We didn't use any conjugate multiplication. We only did perform the division right at this moment. We split into two pieces and performed division right here. So it still counts as a division question, but it wasn't a major question like before. We didn't do any complex conjugate multiplication. Alright.
Can you go back to 18 for a second?
Sure.
I just need this.
This concludes 10.8. Chapter 10 is over. Any questions? You should be now fully ready for the exam. Can we? What?
Can you go back to the other one? I just did.
Okay. Question 20 in review problem set. It says the special product. Do this question fast with the special product formula, but actually there is an also old-fashioned long way of doing this. So why don't you give it a shot for 1 minute? Tell me what you get. But there are two methods you can do. Alright, I mentioned there are two methods you can do here. Actually 3. I want to check this out. Well, if I have a square, I think we have the right to pass the square to both sides. So it's 9 square, and square makes negative positive, and root 13 square. And we know square root and square cancels each other, or in other words, you pass 2 to 13 and $2 paid off the guard, they cancel. So that's 81 plus 13, which is 94. I wonder how you got these answers, but they're wrong. It looks like the answer is 94. Am I right? Am I right? No, it shouldn't be this easy. This is wrong. You cannot pass square for over sum or differences. Only multiplication or divisions you can pass the square in. This is wrong. Totally wrong. So what shall we do here? Square means you double whatever you see in that parenthesis and multiply. So you either go with FOIL here. You not need the FOIL. Now this is too long. I don't recommend. It's not too long, but it's just longer than it's supposed to be. So you can FOIL this first, outside, inside, last terms, combine like terms, square the last thing, etc. I won't do this. This is method 1 you can do. First method. The second one, the real special product form, is this. If you have a difference of square of differences, the fast way to multiply, FOIL this, is you square the first term, plus you square the last term, this is plus, and you put the third term in the middle, which is twice, minus twice the product of the terms, minus 2 times A times B. That special product, if this is a sum, is very similar, A square B square, but 2AB added in the middle, if this is plus. But we won't be doing this. we will do the top one because it's a minus. Okay? So, as it says here, square the first, which is 9 squared, plus square the last, which is root 13 squared. All you need to do is put minus 2 times first, second. This is A, this is B. First, second, multiply twice. Okay? Wow, that's not it. We need to simplify this. 9, compute and simplify. 9 squared is 81. 2 times 9 is 18. This thing is 13. Not over yet. Since these are like constants, we combine them. There is nothing like this, so you just put it in the middle. And this is the right answer. Can I subtract these two and make it like 70 something? No. Because 18 is not separable from root 13. They go together. They are not, these two things are not like. Don't even think about it. That was number 20. Whoa. Yeah, I just type. Okay. Alright, one gone, 29 to go. What's next? You don't pick.
How about number 6?
Okay. Yeah. This is the only question we haven't solved or made an example in class sessions. The rest we always solve something similar. We take this into our workspace. So you better listen carefully here. Alright, what we need to compute here is A circle B of 1. What the heck this means? Circle, do you know this operation? What's the proper name for this circle operation? It's called multiplication product. What is it called? It's called, let's start with a C-O. Composition. This is composition operation. Most people think this is multiplication. They compute B of 1, A of 1 and multiply the results. It's wrong. What this does is you send one. It's like I remember giving this example. It's like there are two machines. There is one part, I don't know what example I gave. I think wood spoon. You provide a tree to a machine, it gives you wood or boards, and the other boards turn into spoons. Okay, so there are two machines here. One is processed by machine 1. It will convert 1 into a number, and whatever that number pops up, it will go straight into the next machine A, and A will process it. We've done these questions with A of X and B of X given. There was formulas given to you in that section, like this, and we processed one in these formulas and computed the results here. In this problem, however, there is no words about the formulas. You are not given any formulas you can process one with. So how do we process them? We process one from the graphs. This formula is actually on the graph. So we need to track where 1 goes in B and then catch that value, and then that value goes into A and go to another value. So again, we first send 1 into B. I want you to compute B of 1. What happens to 1 under B? So you find 1 in x-axis. 1 in x-axis. Here is 1, right? You send it to B. Where is B graph? It's the red one. So ignore blue. Send it to B. And see what point you hit on the graph. And mark its coordinates. This is coming from 1. So x coordinate is 1. What is the y coordinate of this point? What is it? 1, 2, -2. Yep. So first one is the input you put, the one you put here, 1 showed up here. The second one is what 1 is processed into in this machine. B processed this 1 and took it to -2. So B of 1 is -2. Okay? So B of 1 is -2. 1 went to B. It's -2 now. Guess where -2 is going to? -2 is going to A machine now. You're gonna send -2 into A machine. So we restart this question again. So erase this. 1 is processed. It's over. Erase it. Now it's turn for -2. Find -2. Where is -2? Here. There. And it's processed in A machine. Where is A machine? It's the blue machine. You need to go up or down and hit the blue curve, but I am already hitting it. I'm already on it. I don't have to go up and down and hit. One was here. I needed to move towards red to hit this point, but 2 is already on blue. You don't have to move it and hit. It's already on it. All you need to do is read the coordinates of this point. What is it? X is -2, I know, but what is the y value? 0. So A of -2 is 0. Look, I took 1, send it to B, processed in B, and send it to -2, and -2 went to A and turned into 0. The answer is 0. Okay? Do you want to do another one? It's your turn. I'm cleaning this. Same graph. I'm making this, let's say, 2. Can you compute A circle B of 2? First send 2 to B, get a brand new number and send it to A, and that will be your answer, whatever you get under A. Anyone? 1. I think that's right. Let's do it. First, we need to compute 2 is visiting B, B of 2. Alright, I need to find location of 2 and send it to B. So B is the red curve, so I'm sending it into B and getting a point. All I need is its y coordinates. Y coordinate of this thing is 1. No, -1, sorry. B of 2 is -1. Now -1 is gonna visit A. So you need to spot -1 next. Here is -1 and send it to red curve again. Is that right? No. It's visiting A, so A is up blue curve, send it to A, and read that. Minus 1, 1. So the answer is 1. Okay? Got it? Okay. Third attempt. I'm switching the question. Let's say part C. B, circle A, O, -1. Anyone?
-2.
Okay. Any different answers? Let's check. -1 is going to A first. Where is -1? Here. Where is A? Blue curve. Hit the blue curve. And -1 is turning into 1. -1 turning into 1. Now 1 is gonna be processed in B. Here is 1. Processing it in B and getting 1, -2. Yep, -2 is the right answer. Is this clear? Alright, let's switch questions. Next question. Yes, next. Pick a number, Chris. 12. Alright, we need to simplify the expression by using the properties of rational exponents. Properties of rational exponents coming up. Alright, let me pull that for you. So we have a long list of those properties. That's what this section is about. Oh, it should be still on this page. .2. So the hint is whenever you hesitate which section to look at, this is 10.2. We need to go to 10.2 to find that long list. There you go. Here. Properties of exponents. So it's just I lost it. Okay, so let's go back there. Shouldn't be too far. Here we go. This is the list you need. and you're gonna apply this to question here. Okay, so let's review them. Whenever you have two bases with powers around them, you can add the powers. If you have same like bases but different powers, you subtract them. One on the top, one on the bottom. Bottom one subtracts from top. If you have double powers, one inside, one outside, you multiply them. And if you have two bases but a single power, you can pass the power to each base. If division happens inside under the same power, you can pass the power to divisions. And there are two common facts. If you have a negative power, to make it positive power, you need to flip it, make reciprocal. And zero power is always 1. So it's basic 7 rules. Okay? We're going to use them one by one appropriately. So where do you want to start? Which one you want to do first? You want to fix the negative exponents? Negative exponents, change them on the very end. So yeah, in the question they say do not leave any negative exponents, make everything positive. But my recommendation is don't do it at the beginning, do it all the way end, because they are not no big deal. They are not as they're not worse than positive 1 in the process, so they won't have any challenges for us. They won't be challenging. So let's start somewhere else. Take a look at this. What do you see? A to the first power, a to the second power, negative 2. Is there a way I can combine them? If you have a ratio, same bases with different powers, how do I combine them? A to the minus 2, and A becomes A to the minus 2, take away minus 1, they become minus 3. Can you combine these? 128 and 2? Isn't it 128 divided by 2 a whole number, which is 56, right? No, 64. This is gone, that's gone. There is only one pair left, which is B to the first. If you don't see any power around it, it's first power. And B to the negative 5th. How do I combine them? They become B to the 1 take away 5. Negative 5 is 6, yes. Technically this is what you have. 1 minus 5. 1 subtract minus 5 becomes positive, and it's 6. So let me rewrite what we have here. 64, a to the minus 3, b to the 6, 1/3. Next, take a look at these, see which one you can apply there. Tell me the number, rule number. 3 is if you have a single base but double power, one inside, one outside, you combine them. Well, I don't quite see double power around these guys. If I had a double power, I would do it. But I don't have it yet, but we will have it soon. Someone said 4. If you have 2 items in a parenthesis with a single power, you can pass the power to each. But we have 3 here with the same base. Can we still do it over 3? Yes, you can. You can pass the power 1/3 to each. So it's 64 1/3, a to the minus 3 1/3, b to the 6 1/3. Now back to rule 3, this power, because I see double powers now. 1, 2, 1, 2, around these guys. So I will multiply these. Multiply, multiply. What is minus 3 times 1 over 3? Don't they cancel? Minus times positive is minus 1. So this turns into minus 1. This turns into, when you multiply, 6 times 1 over 3 is 6 and 3 cancels. It's just 2. This thing is 2. Oh, look at this. 64 1/3, a to the minus 1, b to the 2nd. Are we done? Are we done? Yeah, we don't like rational powers. If we have them, we change them into radicals. How come? What fact says that? If you have a to the m over n, it turns into a to the m over n. And vice versa, if you have a to the m over n, you can make it nth index of a to the m. So I want to use this direction. I have 64, m is 1, n is 3. Look, a is 64, m is 1, n is 3. That turns into 64 to the first guard is 3. So this thing is cube root of 64. But even better, 64 is actually 4 cubed, isn't it? Isn't 64 when you factor 4 times 4 times 4? This guy is big guy, 64. Have a power 3. He pays off the guard. Actually comes out as 4. So I think we're done. We're through. This is our final answer, right? Is that so? We have a negative exponent. They say leave your answer. Look, leave your answer using positive exponents only. So we need to take care of this a to the minus 1 as this turns into 1 over a to the positive 1 power, or 1 over 8 technically. So it is 4 times 1 over 8 times b squared. Okay, you can put this answer down. There is another way to write it though. 4 1 over a b times something b squared. Or, I don't quite like the look of this thing. If you have fraction and whole numbers multiplied, you can multiply the tops across. This is 4 times 1 times b squared, and you can put 1 under these and across multiply everything. 4b squared over a looks a lot better. You can try this answer as well. Both should be acceptable. Okay? Any questions? Alright, pick another number. We can finish one more. $15. Alright. This is a subtraction question. It says subtract. But you can notice that the sign between two radicals, subtraction of radicals. So remember how we subtract radicals? Oh, I do. All we need to do is we subtract the free guys first. What are the free guys? 7 and 6. What is 7 take away 6? 1. And then we join the inmates to the same prison and subtract them as well. 20 take away 45. 1 times root minus 25. So 1 doesn't mean anything, so you can drop off that. It's negative 25. Oh, this is a sick jail. We can take minus out, and 25 is 5. The answer is 5i. Wait a second. We have complex numbers showing up in section 10.4? That doesn't sound right. So we're doing something very wrong. What did I violate here? What's wrong? I know this sounds intuitive, right? You're tempted to do this. Subtract the free guys, subtract the jails. No, you can't do that. You can't do that. In addition or subtraction of radicals, there is something called like radicals. We subtract, yes, true. We subtract the free guys if the radical parts are matching. These two radicals must match. Otherwise, you can't do any of this. They must match, and they're not matching. So first you need to make them matching. How? By simplifying these radicals. You need to save some people from this prison. Maybe they match that way. So break 20. Isn't it 210, 2, 5? So it's double 2 and a single 5. That sounds good. I have somebody breaking prison here. How about 45? 45 is 9 and 5. Okay. Locked. Double 3, 5. So here is double 3 and 5. And look, these guys are escaping prison because guard wants $2 and they have the bail-off money. So it's 7 times 2. 2 comes out, 5 is in. 3 comes out, 5 is in. And now we have like bases. Look at this. Like radicals. And these are 18 and 14 respectively. Now you can subtract the free guys because you have like radicals. 14 apples minus 18 apples. How many you have? Minus 4 apples. Minus 4 radical 5. Now this sounds better. Okay? Alright, we'll continue tomorrow, but I want you to sit down tonight